Hi, Aaron. Hi, Czech. Another day with you. Pleased to see you again. I put the camera on today. Maybe you see my hand. I used to talk with my hand. Maybe we'll see that. Okay, let's start that session, and I really hope that we're going to have some fun today. It's a topic that I really like, which is testing, and for many reasons I like that part of software engineering, if we can say that like that, or programming, or anything. To me, it's just another tool with other tools that we have to make sure that what we provide to the user is the maximum solidity, if I can tell that, or that we tried our best to catch the most error that can happen. And as a tool, this is also something that we can use, and we are going to see that today, that we can use when we depend on other libraries or other software. And in our case, we are talking about libraries or application that specifically build on top of core Lightning nodes, or maybe they don't build on top, but they have a part that depend for the user of the behavior of core Lightning node. So it's if we can make write some automated test or something like that, that when a new release come, we can ensure that there is no breaking, or if there are, we can catch them easily. So this is the case for today. Also, as a tool, tests are really good for two more reasons that I see on top of my head, which is first to design. So if we have the chance to start with testing and building the things, the program, writing the test at the same time, or before, or really just after we are working, we can tailor stuff and see things that should not be together, that can be break apart. So we have independent part of our system, well tested, and that play together. And another part, it's also an interesting tool for refactoring. So once we have the test in place, and we just want to, it's working correctly, and we say maybe we can improve that part because it's a bit ugly, or I don't quite understand, or I want to rename it, because we can just do it drastically, or the raw way, and just run the test and say, okay, at least what I expected to work is still working. So let's jump into it. A little less bit of a talk. So this was for introducing why I think this is important. And okay, we will run some tests. We will look at the test, but we are not going to write them because I already wrote them before. But we are going to see how we can find them in the case of core lightning. So the example, the library. Sorry, so maybe. New start. Let's go. So the library we are going to use, its name pyln-testing, and we can this link jump us into the Lightning repository, and we have that library, which is a library used inside the Lightning repository to do black box tests. They call them like that, which with that Python library, we can create mini reg tests. So a Lightning network that run on the reg test chain, and we can spin up more as many nodes as we want, and we can bring them together and we can test them. So we can issue invoices, and we can pay those invoices to get the first examples that come in my mind. And those things can be used if we have a library that talk to some node. We can use pyln-testing to create a test, and we are going to see one way. This is not the only way to do testing, but this is something that, as it is offered by Lightning repository, by Lightning, it's cool to use it. So this is the library we are going to use. And before we jump after, so maybe, so we see this is a Lightning repository. You can see at the top in which directory I am. So we are. This is a Lightning repository, and there is a part which is called, so we can look for it, test. So this one, and in that directory, we see that we have a bunch of files that test many things. For instance, this one here tests a plugin written with CLN Rust, so that also the gRPC. We have this one that tests the invoices. We have another one, this one, RenePay, which will test the RenePay plugin. So just to say that maybe we can jump into a terminal, and that terminal into that part of the test. This is not the only test that there is in the Lightning repository, but this is the one that uses the pyln-testing. And we can do maybe quickly clock to see how many files we have and how many things. So we see Python. To me, when I see that, I just say, yeah, that means that we have a lot of tests that uses pyln-testing library. So if we want to write some tests, sure, in the repository there might have some tests that looks like at what we want to do. How to spin up 2 nodes with a channel between those 2 nodes. This can be found in that repository. So we are going to look at some of them and see how to search inside it, but I will show you more how I look around inside that directory to find the piece of code that I need, the snippet that I need to write some other test. So yes, we keep that. We no longer want that, and we are going to go back to, or not. So we are going to use that library. So one example that that I found that I was trying a few months ago to change something in lnsocket, but it happened that it was already fixed. But at that in that occasion, I wrote a test because this is what I do generally when I want to change something or to fix something. I try to write a test that shows the error in cases where this is possible. I know this is not always possible, but this is the mindset. So the mindset is, how can I test something and then see if we can make the test pass by changing some part of the code. So we can really understand that we've changed something that go towards the right direction. So the example we are going to look at that is with lnsocket. Before we look at that example, we can go there and how to do that. Yes, okay. So lnsocket. So this is one of the videos if you want to see after if you missed it. lnsocket, better that one, is a library, a Go library, not only Go library, but we look at the Go library that help let us send command messages to Lightning node. So with the right host name and the name of the node, we can connect to that node thanks to lnsocket and send command messages. And the plugin commando in CLN, in Core Lightning, allow to run command even if we are not the node. So with lnsocket, we are an application, and in this one we did a little web app, a simple web app, where we connect to the node and we say, hey, please give me run some bookkeeper commands and give me back the result. And you see what we are doing. So this is a library really that connect to the node and do something. So at some point we might want to test that library, or if something change in Core Lightning for any reason, we might want to know that those changes happen. And maybe even if they happen and we know that, with the test, we can be sure in some way that if they affect or not. So this is the library, the videos if you want to watch more about that, but it's not about that specific library. It's just an example. And what we can see, we can go to the changelog of the Lightning repository. So that link will make a jump to that thing that this year in February, and something changed. So they are changing that are not trivial, but I want to say that they are not breaking changes on other, and there were a breaking change or called deprecated for the plugin commander. So if you see my cursor, maybe I can do that like that. What I highlight, so plugins commander JSON command without an ID, meaning that at that point, when we send the command message to another node, we send the one part which is the JSON with the method we want to run. We have also a room that is the authorization to run something on the node, and also the parameters. And now it is mandatory to put also an ID in that JSON object that is sent via the connection done via any client that talk JSON messages. So this change, and if your library doesn't send an ID, but it's normal because it wasn't required before, you depend on it, you can run into trouble. But if you wrote beforehand a test that just tests the basic, maybe not all the usages, but the basic usage of how you run the library, you might catch it before your user. I know that the user also catch errors, but the theme of writing those tests is really to not having to rely on the you provide a library, something change that is not in your library, but your library depends on it, and the user or someone building an application. I hope I'm clear with what I'm saying. So this is the game right now. So we have something that changed, and there's a secret deprecation. So if we write, I don't remember exactly, but if we write hello deprecated API true, within a certain amount of time, we still can run the software with the old behavior. But let's say we don't want to ask the user to do that. Okay. So a bit of water. Now, so in that directory, I've already cloned lnsocket with the last test commits, and we have the test. And the test, this is the one that we are going to put into the lnsocket directory repository. Let's see. Let me think what. Yeah. So now, okay, we go to lnsocket. lnsocket, the README of lnsocket, a simple C, JS, and Go library for sending messages over the Lightning Network, and specifically the messages that we sent. This is what I just told you, the commando messages. Okay, fine. So now we are looking for Go. So we go at the top, we have the directory Go, we go into it, and we have the library. So the library is a lnsocket Go, not a big library. We can see the mod line at the is here that 200 lines that depend on some cool stuff from LND. And this is the library, blah, blah, blah. And we can see, I'm showing you where the error is, and this is not how I wrote the test. Okay, so but I just want to show you a little bit the library, how it is written, and all the thing together. I didn't find another way than jumping into the code to show you the part that we need to see to understand what's going on. So, but I tried to do it as if it was the first time. But we see here at some point that function. Okay. That function is a function that wrote on the buffer stream. Yes, on the buffer stream. The part needed, so we need a unique ID here. So this is I don't know if it needs to be unique, but we have to pass an ID of a certain size, and then we can see this is the JSON that I was talking to you just before. So we pass it the method that we want to run on the node. We pass it the parameter on the ring, which is the authorization. And if we were before the last commit, and before 23.02 version of Core Lightning, we didn't need it. We still don't need that one, by the way. But anyway, it's there to it's like if it was following JSON RPC, but it's not required by Core Lightning. But this one is required. So this is that one that makes the library fail if we don't change it and we don't allow deprecated APIs from 23.02. So how can we write a test using pyln library that uses that library and that also run a node on the run a CLN node on regtest. So this is pyln library, and we have to think depending if it was written in Python, it would be easier in the sense that we could write directly and use the library inside the Python test. So this is the kind of the best the best cases if you are writing libraries in Python. The test library is written in Python. Great. But if this is not the case, we still can write an application or a small script that return some JSON, and some in that case we are going to do that with the node ID, and we can try to test to in the Python code get that run that script that is written in Go and that use that library and that talk to the CLN node, and then we can test those things. Okay, so this is what the tests are all about. So let's go back to the test, or maybe before we go back to the test and we add the test, this is my interface, user interface for Git. So this is something that we could have done in how to say that, in the terminal or anyway in your editor, but I'm using mine. So we see this has been merged. So request blah blah, and this one, this is the one that changed that had that ID. So we can look at this one, and we see that this has been merged, and we have something in the Go lnsocket at that point. And now I will put the diff. So this is just the diff, so we don't want this one, and just we see here the diff that happened. This is exactly what I was showing to you. So we don't have before we don't needed any ID, so we don't put it. Okay, that's fine. We've seen the problem. Normally it's at the reverse. We don't see the problem. We try to rewrite the test, and we find that maybe the problem can come from there. Let's go back to our node. So how could we catch that? So there is a test. So we are going to open a terminal. We go in lnsocket Go, and we're going to copy blah 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 blah, and we're going to copy the test here -r, and now we have the test here. Maybe I will take a little break because you might have some question, and I'm ramping on the. So any question? Hey, Solukumar, nice to meet you. So I will wait 10 seconds, drink a little bit. And if you have any question, I can take it right now. Okay, so at any moment, if you have any question, you write it in on the chat, and I will check it. So now let's write a little bit of stuff. So now we can see that we've added the test, and let's have a look on what's in here. So in the README, we see exactly how to we have the things to how to write that. So it could how virtual environments are done in Python. I think there are many possibilities. So any you can do it the way you want. It can be automated, but anyway, we are going to do it by hand. So we need some stuff to install. This dependency is just a dependency for the script that we are going, the script that uses lnsocket library, and then we just have to run pytest and the name of the test. So we are going to do that just in a moment. Now let's look at get info. So this is the script that we are going to use in the test. Okay, because this is a Go library, so we can't use this directly in the Python test. So we need to do something with it. What we can do is to use how to say, it's to write a script. Maybe there are other options, but this is one that we can do. And we see at the top, I'm not a pro in Go, but anyway, this is the way to write that we target the lnsocket library that is in our directory. And so when we make changes, those changes are taken into account. How do we call that library, that script? So go run get info. We pass it the node ID, the host name, and the run. So node ID, host name, and run, we need it for the library. So this is the library that need all this information. One, to connect. This is the node ID and host name. This is necessary to connect to the node and act at the node. And the run is to authorize to run the get info. So this we can see how does it look like. But instead, this is why I'm saying we must, or it's better to write test in that case, because that script we can write it and use it and on our node. Okay, fine. But if the nodes has some properties that changed from another node, what do we do? If someone is working with you, it's better that it can run the test and we all agree that this is working. So the function main. So let's see a little bit. So we take the argument. We instantiate that library. So this is a struct. We generate a key. So we connect as a node. So we need a key to act as a node. Now we connect with the host name and the node ID. If there is a problem, we do something. And here, this is what we do. ln.rpc, this will send a command message with the run, and we run get info. Okay, so maybe you want to run pay, maybe you want to run an invoice, maybe you want to run bookkeeper, depending on what does your application or library. There you might want to choose another method to run on Core Lightning. Get info is the minimum to me. Just that if I get get info running, okay, it's not so bad. It doesn't cover everything. One thing that it doesn't cover is the fact that does it work if I pass some argument. But anyway, just get info, and we don't return the whole object, because in the test, what we're going to do is just to test if against the node ID. So what we do here, we recuperate in the result the ID, and we print that ID. So this is that output. So we're going to run it anyway. So if you I don't think you're lost, but let's say that it's not clear how I'm telling this. That we print out the node ID. So with that output, we are going to be able to use it to do the test with pyln-testing. Okay, so let's continue. Now we have get info. We are going to read the test after, but first so the terminal. In the terminal, what we are going to do is to, as we did in many other, I think maybe in all the videos or on all the live session too, we run that test with a reg test running locally. So to do that, we can use the repository. In the Lightning repository, we have that script that is super cool that we can use. Now to start some nodes on reg test running locally. So hopefully it works. So start ln will start 2 nodes. We don't care that this is 2 nodes because we just want one. Let's check that we have some aliases. So this nodes, to be clear for everyone, if this is the first time that you are with us today. So L1 CLI is just an alias for the CLN node, but with the directory, Lightning directory, being temporary L1 reg test. So now L1 CLI, we can run get info. It seems to be working. Just as show you right now that we have the port. Okay, so this is not going to change as it is in the example in getinfo.go. We have the node ID. We need the node ID, so we take the node ID, and we are going to need a run also. So in the node, let's treat that as a scratch. So we need the node ID. Let's go back into the Go, get info Go, and how do we have to use it? So we need the node ID. Host name, this is that one. So we put it here, and we need the last argument. Okay, so the last argument is a run. We can create any type of run. We are on reg test, and we don't care about if we have a run that is not restricted. So create. So let's just do that. Create run, and that's it. It's not create run. Okay, so we have that run, and that run is an unrestricted node. So if we give that run to any application that can talk to our node via a command client, it can run any command. So we have to be careful with that. In our case, we don't care because we are running locally. So this has the free argument to run that program. So let's go to that terminal. So maybe we need first to do Go. Before doing that, let's go back to the README. I think that we need to have that library installed. So I don't know if it's okay. It seems okay. It seems to be okay. And now we need those arguments on Go. Let's see, Go run, Go get run. It is. I think it's that. Okay. So I forgot to write the name of sorry, I'm blah blah blah. Maybe it's not Go run. Well, I need to go to the test. This is Go run. This is Go run. So that's something that I'm not doing right. Let's go back here. Go run, and no, before the argument, we need to pass it. Ha. Okay, it's for me. I'm not in the test directory, so it won't work. So now we can do it again. So this one should have worked because we are. I don't know if I know that Chuck was in the previous session. I think Aaron, I've seen you once too. That the first command line that I do, it doesn't work the right way. So here we are. Okay. So now it did work. So I will clean this because this is ugly. Everything I did the last 2 minutes, I should have take a break and not do that. So Go run the script that we want to run. Get info Go, not the script, but the one files and the argument. Now we run it. We connect to the node. We get the node ID, and we have that node ID. We can verify that this is the node ID of L1 because if we do that, get info JQ-R ID. And we see that they are yes, they are the same. So we can do that like that. So they are the same. Now we have that application. Why not using it in the test? But this is why we written it in the first place. But we don't have to stop there and say yes, it works, and maybe I don't run on reg test and I just use it directly on my node. No. We can write a test, and the test is short enough to be cool. So now let's look at the test. So I tried to go super fast before doing that. So here we can see that this is something that I wrote 2 months ago, I think. So before using create run, we were using command run. So it's deprecated, but still can be used. And okay, let's go. So we get some of the fixtures that we need to use the test. We write the test and we start it by test underscore something. This is, I think, how pyln-test get what is a test and what is not a test. The not factory. So there are other parameters that we can pass, but yes, this is really simple, and we don't need more stuff for that test. So what we can do with not factory, we can use get node. So this will give us a node, and with that node we can do stuff with it. If we want more nodes, we could have used get node with s at the end, get nodes, and that way we can pass the number of arguments. Here we also can pass option if we want option at starting time. So there are many things that we can do, but let's stay simple. So with that node, now what we do, we have the RPC. I don't know if it's a method. Anyway, so we have that RPC things, and after we can call the RPC class. So sorry, and we have we can call get info, but we could have replaced that by invoice. Okay. Sure. If we replace with invoice, we have to pass argument here. So everything that we see here, this is something that we can check in the check and find in the test repositories that I've test directory I've showed you before in Lightning repository. So we have get info. Fine. Now we get the node ID, because what we want to do, we are going to see after all those things. But the thing that we want is to test at the end. We want to test that something is equal to the node ID. And what do we want to test? So we jump directly at the end, and we are going to go to see the line that we judge. So get info command. Okay, so this is the command that we want to run exactly. Terminal, the command that I was I was not capable to write correctly. So that one, go run get info go, and then we have the information. What are those information? So the node ID, the node hostname, and the run. And okay, so these are the things that we can get here. So node info. This is what we get by the RPC call. The binding, we get the address, the port, and we construct the hostname. And we remember that we needed to have a run. So what we use is command run. I should have changed it for create run, because this is a new way to use it. This is deprecated, but let's keep go with command run. And now at the end, what we do with os.open, we write we run that command. We read the output of that command, and we test it with the node ID. If it's true, fine, we are done. So let's go to the terminal, and now we are going to write that test, and also so the readme to see, do not forget everything. Okay. So in a virtual environment, let's do that. Then we activate that virtual environment, and we install pyln testing. So pip install pyln testing. Okay. Okay, so we should be right. And now we can run pyln-test with the test that we have. So let's do that and see if it's working. We are check out in the master with the last commit. So we expect that that test will run correctly and be positive. So it takes a little bit of time. I think there some stuff to be done, but also I have a slow computer, so it's slow. Okay, it's green. Fine, super cool. So now we've talked a lot. We've seen some pieces. I hope you're still with me. Maybe it's super clear. Maybe you would add something or present it in another way, but we are there. So we have a test, and we can be sure that if we change something, if we break something, we will catch it. So let's go get info. No, this is the script. We don't want to change the script because the script is okay for us. We want to change the library. Okay, let's break the library. Okay, maybe we remove that. Okay. So in that case, if it fails, this is not our fault. This is our fault as the writer of the library. So let's just say that we've done something on it fails. So all I'm doing right now, it's I don't know if I should say it's fuzzy. Just that these are the ideas that comes to show what we are doing. So we can see that failing on I love when a test is failing, because it's just that, okay, there's something that is not working as I expected, but anyway I have a test that tell me what the software is expected. So I love that. I love when they go to green, but also I love to use them as a tool, as using grep or any other tool. So we can see there assert that we have an empty thing. It doesn't give us. So let's see if we have more information. So we have the log. So if you need to see something happen, maybe if you're using a plugin, maybe there's something, maybe there's some logs that can be interesting for you, and we can see at the top that we have a problem in that assertion. So if you have more tests, you will have that information. Okay, it's we can just change that, go back, run it again. Okay, and I will show before we see the changing with the different commits on where we could have catch with that simple test the changing in deprecating changing in CLN. But let's say, so what can we do which would be super drastic? Changing a name, maybe. Okay, so we go back to the test. I was so it works. Okay, so information, we change something. Now let's see if we can do something different, which is I will try to just change that name. But as we have a test, we can be sure that we didn't kill everything. Okay, so it just I did a rip grep. Also there we have all the commando message, that string that is used in that repository, and in specifically just in lnsocket. Now we are just going to change the name because I'm selling you testing. I hope you feel that I'm selling you testing. I really think this is an underestimated tool, so I try to sell it right now. And we are going to just rename those things, not the other one. Maybe with something that foo. Okay, so now we've changed all those lines. If we go back to lnsocket, we have something the new name, and I hope I'm not doing something that is not allowed in Go in the Go language. I don't know, or if I didn't change the name correctly, but it's just to. I'm confident enough that normally I can do that without thinking. I don't have to say, oh, I don't know, I'm not sure, maybe it should. No, if the test passes, so it fails. So this is this show me that I can't do that as drastically. I think that I'm seeing something. Okay. So let's go back. There's something that I've done wrong, and as there's not some. Okay, so this is the way I did it. So, so I did the things the wrong way. I wanted to write through. I don't know what. So let's just, because if this is not that, so commando foo message. Where are the foo? Okay, so just that something. Okay, so this is me. I misused my my tool, and so I did a typo. I don't know how it happened, but anyway, we can check that. Okay. So normally we have the changing. Let's see. Still, those ones are not correct. Sorry, I just take 1 second, 1 minute to check that. If not, it seems that I did everything wrong. We have the changing now. I don't see. Okay, no, it's okay. It's because there's the star. So now this should work. Okay, let's see. Four of these. So I like the red, but really now I would like to have the green. And if I'm not able to make this little part working, okay. So typical. So I wanted to just change the name. I did it. I don't know how I messed up with my my tools, but anyway, we have the test, so we can see that. And now the thing that we want to do. Check out what is the name of that file. So, okay, so we are going to revert that. Okay, so we have it. Okay, so we are back to the normal. We see in the Git interface that there is no longer any changing. So sorry for that 5 minutes of me being lost, but I really wanted to show that what I was saying, that with the test we can do some, we can change stuff, and it's not guaranteed that everything is working, but anyway we have some guard to say that no, it's done wrong or it's done right. Now, one thing that we can do, which is super cool, is that let's revert back to the previous commit. So here we are going to check out to that commit. So up, we are now in that commit. If we go to lnsocket go, we can see that we no longer have that line with the ID. And if we run the test, we should fail. And now, if we see that this is no longer a failure due to our side because we changed something in the software, but it's something that is due to the dependency we have to Core Lightning. So we have that dependency, and we don't get much information about where the error comes, okay? Because just the script that we run, getinfo.go, return now nothing. So something is happening, but what we are sure that we didn't change the library, we still are on CLN, and if we change from one CLN to another release, and we see, okay, so something broke, what happened? We can go to check the log. Maybe we see, something about commando. My library is about the commando, and then we can go to those things. So this is what I wanted to show you with specifically that test. The examples that it can be used. This uses that built on top of CLN. We've seen a use case that can happen because we have a dependency on CLN if we write the application. I will take some questions if you have, and then 5 more minutes we're going to just jump into the test directory and do some great stuff to see that I will show you how I'm looking for a snippet to write test in the repository. So now, if you have a question, I will drink a little bit. Okay, let's go for another 5 minutes, let's say, of those things. So this is done. We have the test, and as usual, as soon as I can, I will put all those things in LN room, so you can check that. Sometimes there is a delay of 2-3 weeks, but anyway, the code will be available. Now, let's go back to the test, and we want to test. Where are we? Okay, yes. So we see at the top that we are in the Lightning repository in the test, and let's go to play. We see that there are many ways to things that we can use with that library, and I think the best way is just to jump into some test and see what it does, and try to have the thing that we want. And sometimes, if it doesn't work the way we think it should work, also to read that part on top of the test that tell us, yes, you need to have that option on to run that test, or that test is not to be slow. So we have the thing. So here we test pay. And we see that we still have the node library, but we use line graph. So I don't remember exactly what line graph does, but it seems that it make a channel, and maybe there are the phones that are taken. I'm not sure, so just I imagine. We see here often we will see L1 and L2. Or L3, L4, L5, because these are the name of the node. So because we want to Lightning 1, Lightning 2, so we use that. So what we can do, here we have the invoice, and if we know that what we want to do is an RPC stuff, we can grep. So I will do a grep, and I will just grep not everywhere, but only in that directory. I will grep for all the RPC. Okay, so now we see we have at see on top right we have about 3,000 hits. Okay, so we can see those things. So for benchmark, we have get root, send pay, and what's cool is that we see how the arguments are passed. So we can go here where we have connect. If we need to connect, we can go to that one. Let's see that one. Okay, so we are here. We know that the test create channel and see it being updated in time before pruning. Maybe this is something that you need. I don't know, but here we can see how it's done. So we get some nodes. We want 3. Here we have the option that we want for the node. So up, if this is something that we need, up we can just pick that one. We want to connect. Okay, so we can connect. We need the info and the ID of the node L2. Here we can see how to find a channel, and then for instance, there are some utilities, because when it's not, I don't think this is the case for app on the libraries, but anyway, I talk about it maybe for plugins. So sometimes we need to wait. See this one, yes. So we need to wait that something happen in the network before we continue and do something. So we have that function wait for instance, utility that this, okay, we are going to do something and we wait till we get 4 true. So it seems to be to have all the channel activated. Okay, so there's something like that. Maybe last thing. Okay, this one. We have also daemon. So daemon let us do some other stuff. On the node. On this one specifically, we see we have daemon and we wait for log and to see something happen in the log. So maybe this is something that we want, or maybe you transform. What we could do again. So we go to the not that one, this one, and we change not for LPC. So look at the bottom. Daemon L1 daemon. Okay, we have wait for logs, and we have about 1,000 hit is in log, and we can go on and on, but we can check those things. So yes, we are done with testing, how to find information. I hope really that I did my best to sell you testing. So I hope it wasn't boring. So okay, so the question from Aaron, just to confirm my understanding, lnsocket is a library that CLN depends on. It's a separate repository. Okay, sorry. So if it wasn't clear how I say that, so maybe I will answer right away, but sometimes it's better to see it in the web interface. So lnsocket, as we can see, you can see, Aaron, that this is another library. So this is not part of Lightning repository. This is a library that how to say that? So I go back here. Sorry, where here. So this is a library that a Go library. So this is to use in Go programs, and in a Go programs, that what you want to do, you have a node, or your user have a node, and you are writing an application in Go, and you say, how can I get information from the node, for instance, to issue invoices, or to pay invoices, or to send custom messages, or to do something with the node. So there are that library that can do that. There are other plugins that you can do HTTP request to the node to get those information as the new CLN REST in the last release. But really, this is another library, Go library, that talk to the node. So it talks to the node. And what we did today is really to see, as that library is talking to the node, how can we test to be sure that when the node change, our library still run correctly. So it was the goal of today. And so what we did, we write a getinfo.go programs in Go, where we use that library, and with that library, we've connected to a node that run on regtest. So this is fake money, if I can say that like that. So we are not on mainnet, we are on regtest, and we did the things, we communicate with that, and when we change from one commit to another, not in CLN, but in that one and CLN change, we get that. Okay, sorry, Aaron. Thanks for. I was. It seems that I was ramping. So no. Okay. Maybe. Okay. So maybe I messed. Messed things up by showing two parts. So no, they are in different repositories, and I can show you that. Thanks for stopping me and making the thing clear. So here we have the Lightning repository, the lnsocket repository. So I go into the lnsocket repository. I go into the Go part of that repository, and we added, sorry if it wasn't clear, we added that test directory to test lnsocket Go. And then what we did is also to go in the test repository of the Lightning repository to see how we can we can get information in the Lightning repository. Sorry if it wasn't clear. Is it clear enough now? So two separate stuff. Okay, another question. Okay, last question. If I'm writing a plugin, is it possible to spin up ln nodes using the startup script, which register my plugin in my development environment? Yes, the answer is yes. And maybe you haven't seen yet the so LN Room. So I encourage you to go on the lnroom.live, and we did many videos that really do what you're asking. So from the first live, understanding CLN plugins, registering a JSON RPC, and you have a bunch of example. And I don't know in what language are you writing your plugin? So tell me. We did that in Bash, Python, and we also have videos to write a plugin in JavaScript, Go, and Core on the Rust. So you have 5 languages with example in okay, Rust. So I give you directly the link. I don't know, because maybe you are using, depending of if you are using CLN for Go, for Rust, or if you are using the up. Okay, so this one uses CLN. Don't remember the name. CLN-plugin, and this is the library, the Rust library provided by Lightning upstream. If you are using CLN for Rust, I didn't make an example with that, but here you can see an example how it works. Okay, cool, Aaron. And also Chuck and Soru Kumar. I don't know if we pronounce well. I'm super happy to have spent this time with you talking about the test, one of my best preferred topics. And thank you also, Drew. Maybe we can stop. What do you think? You're there, Joe. Okay. So see you in the next live session, guys. Really have a good time with you today.